In this video, I picked out 3 different multiple choice questions from Suvat equations. Specifically, this first one is quite difficult, so let's sort of draw our own diagram to label it. We have a mass x of 2m. It's projected vertically upwards with the speed u meters per second. There's another one, which we call y, with a mass m. That's projected at 30 degrees to the horizontal. So we can draw that on as this sort of angle here. And it's projected with a speed of 2u meters per second. It then asks which of the following statements is correct. The horizontal component of y is u. So let's break that down. We have a right angled triangle here with the hypotenuse is 2u, this angle is 30 degrees. How can we find the horizontal component? Well, the fact that this is a right angled triangle, sorry about my diagram, but it's supposed to be a right angled triangle. We can use the fact that this is the hypotenuse and this is the adjacent, and we can say that cos of the angle 30 is equal to the adjacent, which we want to find, divided by the hypotenuse of 2u. Multiply both sides by 2u and you get 2u cos 30 is equal to the adjacent, and cos 30 actually itself is root 3 over 2. So we can say root 3 over 2 multiplied by 2 is root 3. So this becomes u root 3. That's not u, so this is incorrect. I'm just going to clear some of this up just so we have space to show the rest of the question. It then asks whether the maximum height reached by x is half that reached by y is half that reached by x. How do we find the maximum height? Well, if we form Suvat equations for both variables, let's break them down. The vertical component of u is, well, we found the horizontal is 2u cos 30, so that means that the vertical will be 2u sine 30. What sine 30 equal to? It's actually equal to a half, and 2 times a half is, well, just 1. So we can just say that the initial velocity is u. That's the same as it is for x actually, because it mentions that earlier on in the question. We know they're both sort of going upwards in the vertical direction, so they both have minus g as their acceleration, minus 9.81 that is. If we want to find the maximum height reached, that's, well, at the maximum height we know the final velocity is 0. On top of that, if we look at the variable s, well, it doesn't matter which equation we use. But using SU, V, and A, what we see is that everything matches. So that means that the height reached is exactly the same by both particles. So this is false. It's not half that it is for x. Now, what's the correct option then between C and D? It's actually going to be C, and I'll go through why. It's because, like we mentioned, the initial velocity is the same, the acceleration is the same. In that case, what we want to compare is the time. And we also know that S, the total value that it falls, is also the same. The reason we know that is because it says that it's being projected at the same time. So they're both going up with the same initial vertical speed. They both have the same initial acceleration. They both have the same initial displacement from start to end. And so the time taken of the journeys is also the same. So it's going to be option C. Great. Let's now move on to this question here. What relationship between distance traveled, y, for an object falling freely from rest, that's important, at time x? So once again, let's label up the Suvat equations. If it's falling freely under gravity, that means it's going downwards in the direction of gravity. If it's going in the direction, that means that's positive 9.81 for the acceleration. It's told you that the time taken is represented by x, the distance traveled is represented by y, and on top of that, the fact that it's falling from rest means that its initial velocity is 0. What equation links S, U, A, and T? Well, it's S equals ut, which is 0 times x, plus a half of A multiplied by t squared. A half of 9.81 is just 4.905, so this is what y equals 4.905 x squared. Now, because this is a constant, what we can say is that y is directly proportional to the square of x, and so option A is the correct answer here. Let's now turn our focus to this last question. It says the velocity of a particle with time is shown by the following graph. Which one represents the resultant force F acting at the same time? Well, what's an equation relating to resultant force? It's resultant force equals mass times acceleration. Because mass is constant, the resultant force is affected by the acceleration. And how do we determine the acceleration of a velocity time graph? Well, actually, the gradient of the graph, and the gradient of any graph, gives you the change in the y-axis, which is the change of velocity, divided by the change in x-axis, which is change in time, which essentially is the equation for acceleration. if we look at the gradient, what we see is that it's pretty low here, then it's increasing, and then it's the fastest, and then it starts to slow down again, and the gradient gets smaller and smaller. So in these curves, because force matches the acceleration, they're directly proportional. The force follows the same pattern in that it first increases very quickly, and then it's still increasing, but it's increasing at a lower rate. That's why C is the correct option, because this gradient is increasing very quickly, but then it's still increasing, but it's increasing at a lower rate. The gradient's never decreasing, so it won't be this. Again, it's never decreasing, so it won't be this. And again, it's never decreasing, so it won't be this. Hopefully this video all made sense. And if you have any questions about anything, these are pretty difficult multiple choice questions. I picked them from a specimen paper. Be sure to leave them in the comments. Otherwise, be sure to like the video and subscribe. Thanks for watching.